Download this code from codegive.com, link in the description below. Vista Infosec boolean-based SQL injection, a detailed tutorial. This tutorial provides an in-depth explanation of boolean-based SQL injection, specifically tailored to the context of Vista Infosec's training materials. We'll cover the underlying principles, detection techniques, exploitation strategies, and provide concrete code examples relevant to Vista Infosec scenarios. Disclaimer *: This information is provided for educational purposes only. Using SQL injection techniques without authorization is illegal and unethical. Only use this knowledge on systems you own or have explicit permission to test. Prerequisites ***. Basic understanding of SQL, especially select statements, where clauses. *** Familiarity with HTTP requests and responses. *** A testing environment, example a vulnerable web application you've built or have explicit permission to test against. A Vista Infosec VM or lab would be ideal. What is Boolean-based SQL injection? Boolean-based SQL injection is a type of blind SQL injection. Blind means you don't get direct output from the database in the response. Instead, you infer information by observing how the application's behavior changes based on the truthiness of the SQL conditions you inject. It's Boolean-based because you're exploiting the application's behavior based on whether an injected SQL expression evaluates to true or false. This is in contrast to error-based SQL injection, where errors generated by the database reveal information, or union-based injection, where you can directly append your own queries to the original one. Why is it called blind SQL injection? Because the application doesn't directly display the results of your SQL queries. You don't see the output of select version, or select * from users. Instead, you observe changes in the application's response, a difference in a status code, a change in rendered content, a different redirection, to determine whether your injected SQL query evaluated to true or false. The core principle ***. You craft SQL injections that result in true or false conditions within the original query. Then you analyze the application's response to infer whether your injected condition was met. If the condition is true, the application behaves one way; if it's false, it behaves another way. Vista Infosec relevance. Vista Infosec's labs and training materials often include deliberately vulnerable web applications designed to demonstrate various security vulnerabilities, including SQL injection. Boolean-based SQL injection is a common type tested within Vista Infosec environments. Often these labs focus on parameter manipulation and exploiting insecure coding practices within web forms. Scenario ***. Imagine a website with a user search functionality. The URL might look like this. The search.php script takes the keyword parameter and uses it in an SQL query to search a database. A simplified, vulnerable query might look like this. Notice the lack of input sanitization. The $keyword variable is directly injected into the SQL query. This is ripe for SQL injection. Exploitation steps ***. 1. Identify a potential vulnerability ***. Look for web forms, search boxes, or URL parameters that take user input and likely incorporate it into a database query. Observe the application's behavior when you enter different inputs. Does it return different results or error messages? A key indicator is seeing different results based on the length or type of the input, which can hint at server-side errors caused by mishandling data in SQL. 2. Initial test for SQL injection ***. Try injecting a simple SQL syntax error, such as a single quote. If the application displays an error message related to the database syntax, it's a strong indicator of SQL injection vulnerability. Asterisk example URL. Asterisk if you don't see an error, that doesn't rule out injection, just direct injection. We'll continue. 3. Confirm vulnerability with boolean-based techniques asterisk. Asterisk test with and or operators asterisk. Asterisk the goal is to inject a condition that will always be true, and another that will always be false, and observe the application's response. Asterisk true condition asterisk. This effectively adds n1 equals 1 to the SQL query. Since 1 equals 1 is always true, the original query's behavior should be unchanged, or slightly changed. If the application returns the same results as the original query, http://example.com/search.php, keyword equals test, it is a good indication of SQL injection. Asterisk false condition asterisk. This adds n1 equals 2 to the query. Since 1 equals 2 is always false, the original query will likely return no results, or a drastically different response. Asterisk important note asterisk the specific syntax might need adjustments based on the database system, example MySQL, PostgreSQL, MS SQL. Asterisk example explanation asterisk. Asterisk original query, vulnerable select asterisk from products where name like %test%. Asterisk true injection asterisk select asterisk from products where name like %test and 1 equals 1%, result, likely returns results similar to the original query. Asterisk false injection asterisk select asterisk from products where name like %test and 1 equals 2%, result, likely returns no results. For information gathering, database version, user. Asterisk now that you've confirmed the vulnerability, you can start extracting information. You'll use Boolean logic to ask the database questions and infer the answers based on the application's response. Asterisk example, determining the database version, character by character. Asterisk will use the version, function, or its equivalent for the specific database, and the substring, function to extract the version character by character. Asterisk target asterisk determine if the first character of the database version is 5. Asterisk injection payload asterisk. Asterisk substring, version, 1,1, extracts the first character of the version, function's output. Asterisk equals 5 compares that character to 5. Asterisk dash dash is a comment operator in many SQL dialects. It prevents any subsequent code from interfering with the injection. Asterisk analysis asterisk. Asterisk if the application returns the same results as the original query, it means the condition is true, the first character of the version is 5. Asterisk if the application returns no results, it means the condition is false. Asterisk iteration asterisk repeat this process, incrementing the substring position, 2, 3, 4, etc., and trying different characters until you piece together the entire database version. 5. Extracting data, database name, table names, column names, data. Asterisk the same principles apply to extracting data. You'll use Boolean logic in conjunction with database functions like database, table_name, column_name, and data and the information_schema tables, or equivalent for the database, to gather information. Asterisk example, determining the length of the database name asterisk. Asterisk this checks if the length of the database name is 8. Adjust the number until you find a value that makes the condition true. Asterisk example, finding a table name asterisk. Asterisk this is a more complex example. Asterisk, select table_name from information_schema.tables where table_schema equals database, limit 0, 1, selects the first table name from the current database. This is a MySQL-specific query. Other databases have different approaches for accessing table names from system tables. Asterisk substring 1, 1 extracts the first character of the table name. Asterisk equals U checks if that character is U. Asterisk limit 0, 1 is used to retrieve only one record from the result set of the subquery. This is necessary because some databases do not allow comparing a string to a result set containing multiple records. Asterisk iterate through characters and table positions, using limit or equivalent, to enumerate all table names. Asterisk extracting column names and data. Asterisk the process is similar. Use queries to access column names and data from the tables you've discovered, character by character. Code example, Python script for automation. Explanation of the Python script. Asterisk check _true false, URL, payload _true, payload false, asterisk. This is the crucial function. It takes the base URL, a payload that should evaluate to true, and a payload that should evaluate to false. It sends HTTP requests to both URLs. You must modify this function to correctly analyze the application's response. For example, check the HTTP status code, example 200 OK versus a redirect. Examine the HTML content for a specific string that indicates success. Measure the response time. Sometimes a true condition might be slightly slower. The correct behavior to check varies from application to application. Returns true if the true payload leads to a different response than the false payload, allowing you to distinguish true from false conditions. Otherwise, returns false. Get _database _version, URL, This function demonstrates how to extract the database version using Boolean logic. It iterates through possible characters, ASCII 32 to 126, and uses the substring function to extract characters from the version function's output, comparing to each character. Adapt this function to extract other data, table names, column names, data, by modifying the SQL query within the payload _true and payload _false variables. Important the script is just a starting point. You'll need to replace http://example.com/search.php keyword equals with the actual URL of your vulnerable application. Adapt the check _true false function to accurately determine true versus false responses for your specific target. Mitigation techniques. Input validation and sanitization. Never trust user input. Sanitize all user-supplied data before using it in SQL queries. Use parameterized queries or prepared statements. These techniques treat user input as data, not as code. This prevents attackers from injecting malicious SQL commands. Least privilege. Grant database users only the necessary permissions. Avoid using the root or SA, system administrator, account for web applications. Web application firewalls, WAFs can help detect and block SQL injection attempts by analyzing HTTP traffic for malicious patterns. Regular security audits and penetration testing. Regularly assess your applications for vulnerabilities, including SQL injection. Escaping user input. If you must dynamically construct SQL queries, use database-specific escaping functions, example miscli _real escape _string in PHP, to properly escape special characters. However, parameterized queries are strongly preferred. Error handling. Avoid displaying detailed database error messages to users, as they can reveal information that attackers can use to exploit vulnerabilities. Vista Infosec considerations. Labs. Vista Infosec labs often simulate real-world scenarios. Pay close attention to the lab instructions and any hints provided. They may guide you towards specific injection points or techniques. Training materials. Review Vista Infosec's training materials on SQL injection. They will likely cover best practices for secure coding and vulnerability mitigation. Ethical hacking. Remember to always obtain explicit permission before testing for vulnerabilities on any system. Conclusion. Boolean-based SQL injection is a powerful technique for extracting information from vulnerable databases, even when direct output is not available. By carefully crafting SQL injections and analyzing the application's response, you can systematically reveal sensitive data. Understanding the principles and techniques outlined in this tutorial is crucial for both offensive security testing and defensive security practices. Remember to always prioritize secure coding practices and use proper input validation and sanitization to prevent SQL injection vulnerabilities. Be sure to tailor your attacks to your target and adapt your Python code to properly catch the status of the HTTP request. This will ensure you extract the information in a timely manner.